Okay, this is CET236 homework 6 about Thevenin and Norton, problem 3. So the first two problems we could use, first one we could use equivalent resistance technique, second one we could use open circuit voltage short circuit current technique. This time we have no independent sources, so you can see the blue highlighted ones are both dependent sources, so we've got to use the apply a voltage technique. So in this one I've decided to use 100 volts as the voltage I'm applying, and so positive, I've got my current is I nu, and the idea with this one is that the Thevenin resistance is equal to V nu divided by I nu. We already know what V nu is, but the trick will be to figure out what I nu is. And to do I nu, we need to do mesh analysis. Well, we can do mesh analysis, and so I've selected 3 meshes. The nice thing is we get a freebie because this current source only has one mesh current flowing through it. So IS, IS is just the mesh current for that mesh. So then the blue mesh, I nu, we get minus 100 because we're going into the minus side, plus 14 because R2 is 14, times I nu minus I1, just make the arrowhead on that look a little bit clearer, right? And that's a pretty simple equation. And then the next one is going to be I1, and here we have again R1 times, this time I1 minus I nu, and then plus 450 times IX, right? There's the VS dependence. So IX is this current here, and IX is nothing more than IS plus I1, which means we have 24IX plus I1, right? Because IS is 24 times IX, and we can rearrange that to see that I1 is 23 IX, or IX is minus, sorry, I1 is minus 23 IX, or IX is minus 1 on I1. Of course, the other way to see that is because we want IS. IS is 24 IX, so IS is minus 24 I1 on 23. Okay? So then we can do, so we've already done R1, then to get and I think I've done this incorrectly, so let's just get the small erase and erase that out. Right, so then, so we've got, let's just check them off as we go. Let's go with green. We've done this one, which is this one, and then we need to do R2. So if we're going around this way, R2 is, actually, sorry, that is R2. I got the wrong one. Let's try that again. Right, so this is R2, 14 times I1 minus I2, and then we get plus VS, and VS is 450 IX, so that's 450 times minus I on 23, So that's let's go with this one. So that's this one, right, and this one. And then we need R1, which is 400 times, now what is it? 400 is 400 times I1 plus IS, and IS is minus 24 on 23 I1. So this is going to be minus, let's just correct that, it's minus 24 on 23 I1, right? So it's I1 plus IS, here is I1, here is IS written in terms of I1, and that whole thing equals 0. So then we've got, what do we got? For I1, we've got 400 I1 plus 14 I1, that gives us that. Then we've got 24 times 400 minus 24 times 400 on 23 I1, and we've got minus 450 on 23 I1, and then the only IU component is the minus 14 IU. And from there we can put it into a matrix. Let's see if we can write out the matrix. The matrix should be up here, and let's just get the right I1 coefficient, right? So the first one is 14 I nu minus 14 I1 equals 100. And the next one, we only have a minus 14 I nu, so that's there. And then we've got this equation here, or this, so that's 414 minus 24 times 400 on 23 minus 450 on 23, right, and that equals 0. From there, I should have scrolled that up so you could see it. Oops. So there, from there, we can put it into the matrix. So there's our 14 minus 14 minus 14, 415 minus 24 times 400 on 23 minus 450 on 23, and that gets us our 22.53. We're not done yet. That's our RTH, right? So we have to also find the VTH, and the VTH is nothing more than looking at the open circuit voltage for the same circuit. Right, so let's, I've drawn all over this, so let's see if we can't go over here and insert the same picture. This is question 3, I think. Here we go. There's question 3. Right, and there's the picture. Okay, so now we need to find the open circuit voltage, right, VOC. And how do we do that? Well, we've basically got to do the same sort of analysis, right? We have an IS, and we have, which way did I make that one go? I think I made it go that way, right? So that way, and we want to find, let's call that I1, right? So again, let's do IS. IS is 24 IX, and IX is IS IX is IS plus I1, right, and IS is 24IX, so it's IX equals 24IX plus I1, and we get the same equation that we got before, that IX equals, what's that, minus 1 on 23 I1. Okay, and then our I1 equation is going to be R1, which is 400 times I1 plus IX, which is minus 1 on 23, sorry, IS. That's the mistake I made last time. Let's try that again. So that's going to be again 20 minus 24 on 23. Right, I1. And then R2 is going to be, where's R2? It's plus 14 times, this time it's just I1, there's no I new, and then plus our VS, which is now 450, don't know why I wrote 240, 450 times IX, so that's going to be oops. No, it's not letting me select the, there we go. Right, so it's going to be 450 times 450 on 23 times I1, and that equals 0, and we don't have any other unknowns, we've just got I1. So I hope you can see that we have I1, I1, I1 and I1, so everything is equal to 0. We've just got a coefficient times I1, so that implies that I1 equals 0, which is the current, and then the open circuit voltage is just going to be, well, if we do it around like that, it doesn't really matter because the answer is 0, right? It's going to be R2, which is 14 times I1, which is going to be 0 volts, which is what we got. Okay, that one was a bit more complicated than I thought because I made a mistake the first time I tried to do this. So ask questions during class on Saturday if that's